atomic size. So in 32 and 33, it's basically the same question, but what's the difference that what happens in a row versus what happens in a column in a family? And we've been looking at that trend in the families. We're adding energy levels. That's going to increase the size. In a row, as you go from left to right, you're going to decrease the size. All right, 34. Why atomic radius changes going down a group? I think I just said that.
We did that.
Well, this test is so repetitive.
It is.
35. Ionization energy. What is that?
That's the amount of energy you have to give an atom in order to get it to give up one of its valence electrons.
You're kind of like buying an electron with some energy, right?
How much energy you have to give an atom in order to get it to release an electron. So what kind of ion are you trying to make?
Well, I guess if it's something that's going to release an electron, it's going to get rid of some negativeness, so negativity. So it must become positive, and that would be a cation.
Okay, so forming a cation costs some energy.
Yeah, now we've been talking a lot about atoms losing and gaining valence electrons to get to that outer shell that's stable, or get to the stable outer shell underneath. But remember, atoms are perfectly fine being neutral. You know, same protons, same number of electrons. So we do have to add some energy to a metal atom to get it to give up its valence electrons. It's not very much energy, though. That's how we know it's okay with giving up valence electrons, because then it's going to bond and it's going to be joined with something else, and it's going to share that or trade off and get that stable outer configuration. But it's not like the atom's just sitting there spitting off electrons for no reason. Energy is taken in by that atom, and then it gives off or loses its valence electrons. The metals.
Was this question about the trend?
No, it's the question. No, it's just in general, what is ionization energy?
The next couple of questions are indeed about the trend. So atoms in general are happy being neutral, but some of them give up their outer electrons. They're not just throwing them around, but some of them give up their outer electrons, you know, at just a little whisper. They'll give up their electrons. Where are those elements? Well,
where are those that react?
Those elements that like to give up electrons have to be over here, because metals form cations. And those electrons probably want to be far away from the nucleus. Right? Because distance diminishes the attractive force. And shielding effect diminishes the attractive force.
Less pull.
So if we're talking about metallic elements and then big metallic elements, we're talking about these guys down here. So ionization energy actually decreases.
Decreases there. Ionization energy is going to go the opposite of this.
Decreases.
Because remember, this is energy we have to add to the atom. So our IE is going to increase over here and up here. Okay. This is energy that we're adding to the atom. Some other substance that's wanting to bond with the atom, in order to kind of pull away those outer shell electrons. And the metals are okay with doing that. That's why the trend is opposite. It takes a lot more energy up here in this corner, where the elements are that want to keep their valence electrons and even add some more.
Because they're so close to being full. They're so close to having that full valence energy level. It's hard to break that up. These guys over here, those valence electrons are so far away from the nucleus, it's almost a miracle that they're still hanging into an orbit. So just a little bit of energy is done.